is, as you can see, a talk about getting to continuous deployment. Just adjust this a bit so I can see it. So yeah, continuous deployment, it's a strategy in software development where code changes to an application are released automatically into the production environment. Simple, right? Yeah. So this talk is more about all of the things you need in place to get to continuous deployment. It's not necessarily a talk about how you set up some continuous deployment server somewhere out there in the ether. It's more about getting to it. But I might show some of the tools and systems we're using at the end if we have time. And if you have questions, just jot them down. And if you want to refer to a specific point, there's a number in the bottom right-hand corner that you can then ask me about a specific point. Should be plenty of time at the end for questions. Just a little introduction to me. Usually I don't do this, but it's kind of relevant here. Let's adjust this a little bit. There we go. So yeah, I call myself a backend API / developer. Perl, Python, Bash, Ruby, C, but very rusty. And it's kind of largely in the payment space, often kind of backend banking integration kind of stuff. And I've been doing this for 20 years, which is quite scary. I've actually only worked for 3 companies in that time, so I've seen tech stacks grow from small to medium to a bit larger. And I'm kind of more in a site reliability engineering role these days. So that's kind of the stuff I'm doing. I'm kind of writing stuff and then throwing it over the fence for somebody else to deal with, but having to deal with the production issues myself. And I've often been involved on the kind of deployment side of things, and including 3 a.m. starts. I don't know how many of you remember those or still do those. Yeah. So I've written a few tools around that in previous jobs and my current job. We don't do 3 a.m. starts in my current job, fortunately, but I have sat next to sysadmins literally typing in commands at 3 o'clock in the morning and thinking, we can do this better, right? I mean, and I consider myself a pragmatist, not an idealist. And on that last point, I put this tag into the ACT tags, quixotism, which is impracticality in pursuit of ideals, especially those ideals manifested by rash, lofty, and romantic ideas. It also serves to describe an idealism without regard to practicality. So really, we kind of need to consider the practicality of getting to continuous deployment. And there's 2 kind of practicalities I want to talk about here. So obviously the technical side of things. And, what state is your current deployment process in? How easy is that? Can you deploy any of changes without having downtime? Do you need a large maintenance window? I'm working in the banking space, the payment space. We often get alerts of maintenance windows from banks saying, we're going to be having a maintenance window this Saturday. It starts at 10 o'clock in the morning and it ends at 8 o'clock at night. And our rollback window, it runs until 3 o'clock the next morning. So, they're still working in we need to take 12 hours to have a maintenance window. You can't continuously deploy that, obviously. And obviously, if it's something like that, you need to babysit it. You need to sit there and do all the stuff you need to do and then check the logs and roll back. And yeah, it's not fun. You're often running commands manually, restarting things, applying DB updates manually, which is never fun. And yeah, you need to see how your monitoring is. You can't think about continuous deployment if your monitoring systems are non-existent or not good enough. How quickly do you know that production has an issue after a deployment? Do you know that during the deployment? Can you very quickly roll back? And who gets alerted to that fact? Because, if you've got a bit of a disparate monitoring system that somebody who's maybe on holiday gets the alert, then that's no good. You need to get the alert if you're doing a deployment. And on the alerting side, then there's obviously the practicality on the human side of the things. I don't want to be woken up at X o'clock in the morning because somebody has merged something into main because they couldn't sleep and they had something on their mind, and it's like, oh, I can fix this now. And obviously, I like to have my weekends free of work stuff. Um, Friday evening counts as part of my weekend, and we're working a lot more in a distributed space now. So we often have people not working the same hours. I mean, this has kind of always been the case, I think, in our niche, but even more so now. Maybe you've got a team in another country and they're not synced with you, so you need to keep this in mind. And the Fangs, they have SRE teams that are bigger than your entire IT department, and often by an order of magnitude. So it's easy for them to wax lyrical about how good continuous deployment is when they have 300 engineers dedicated to just keeping the site running. So that's one of the things you have to keep in mind. They have 24/7 SRE coverage, which most of us are not fortunate enough to have that. And prod is going to have issues even when you don't make changes, especially in cloud environments. This is some of the fun things I've been learning about working with AWS. I've been collecting these. So sometime in the future, I will give a talk about the interesting failure modes in cloud computing, but that's another time. But things fail on production and things stop working even when you don't deploy code. So kind of by definition, how are you going to make changes without breaking things? This change can't possibly have any impact. I disagree. And you're inevitably going to lose an evening or a weekend at some point, even with no deployments. So reduce the chance of that happening. I read a blog post recently about somebody saying we deploy all the time. We don't have change freezes on a Friday afternoon, and then they gave figures about the outages they'd had and said we only had X outages on a Friday afternoon or on a weekend, and the fact that that was greater than zero was a bit of a red flag to me. So saying we're happy to deploy stuff, but then things break and we need to pull people in and they lose their weekends, which is, not great. And the thing to kind of note about that is, when do the most production outages happen? It's generally when developers are making changes and deploying changes. Think about the big sites. They tend to be up and running over Christmas. They don't go down when all the engineers have kind of gone home for the holidays and they're not making changes. So I just wanted to talk a little bit about our infrastructure at PayProp. So long before I joined in the early 2000s, it was literally a single server sat in an office somewhere in Stellenbosch, which is South Africa. And it's pretty easy to deploy to that. I mean, it's literally there and you can just tie stuff up and copy it across. And we had root on everything, obviously. But time has moved on. And when I joined in mid 2013, we were deploying to AWS. So this is a very, very simplified architectural diagram. I've left a lot of stuff out because it's not relevant to the talk, but the things relevant here are those in orange. So we have auto-scaling web servers, and we have a batch server, and we have a processor server. So a few things that we deploy code to, deploy changes to. And the current situation is that basically times 4. So we were in 4 different regions in AWS. And we've also added some more daemon servers. So again, the orange things, little orange boxes, are the ones of concern. And yeah, as I say, this is in 4 regions. So we've got North America, EU West, Ireland. We haven't moved to Cape Town yet because we're not yet convinced that they can cope with the amount of load shedding that happens in South Africa. Yes, but that's in the works. And yeah, basically, as I say, we deploy to web servers, batch servers, and daemon servers, which all have apart from the batch servers, they have auto scaling. And what we do is we handle payments and reconciliation for the rental industry space, which means the way our traffic happens is we tend to get our busiest period at the end and the beginning of the month when everybody is paying their rent. And then we get small spikes at other times of the month as well. So we have a very good idea of what our traffic pattern looks like and when the risk of doing a deployment is higher. And it's the last Monday in the month, so today is a very busy day. Probably not a good idea to be away from the office at a Perl conference, but you know.
No, this is how you build trust.
Yeah, so in our quietest case, we have about 20 servers to deploy the code to, deploy changes to. In the busiest case, it can be at least 100 servers. And as I say, it's spread across 4 different AWS regions. And I consider this large enough to mean automated deployments are necessary, right? Because nobody wants to be manually deploying code to this many servers. But it's actually small enough where automated deployment can actually cause problems. Because if you have thousands of servers or tens of thousands of servers, and you start doing rolling release and you quickly realize there's a problem, you can stop that release and roll back, and you've only affected 1 or 2% of your fleet. The problem with our infrastructure is it's small enough that we can do a deployment and it's finished by the time we realize there's a problem. So that's one of the things to keep in mind. But really the minimum threshold for automated deployment is probably 1 server anyway, because, automate all the things. So just to talk a little bit about how our deployment works, or worked. So as I said at the beginning, it was literally just some tarballs that were just sent to production and unzipped. And then it became bash scripts, and then it became a Perl script that's configuration driven when I became annoyed by the bash scripts, and also when we went into different regions, so we needed configuration to define all the different places we're deploying to. And the future aim is kind of containerization, so images, containers, whatever. These things have kind of been the spanner that's been thrown into those works, because now we have to support M1 Max, which means we're using Docker, which means we're going to need to get that in production. So it's in a little bit of flux at the moment. So yeah, getting to continuous deployment. What are the things that need to be in place before you even think about continuous deployment, and how do they help? And how do they hinder? So I'm just going to go through a few of the things I think you need before you think about continuous deployment. Consistency. So when I arrived, we were using System Perl, and it was all over the place. It's not good enough. You need the same version of Perl running everywhere, from your dev all the way through to production. And you need the same version of the libraries installed as well, because if you're CPAN-ing or whatever on prod, you're going to potentially get a different version. So you need consistency there. And the same goes for the operating system, because you're probably relying on binaries or shared libraries in there. And obviously the same version of critical dependencies. As I said, this is for dev all the way through to production. Obviously, you're going to have times where it goes a little bit out of flux. I mean, we always feel to be on, it feels like we're always on an upgrade treadmill all the time now. I mean, everything is always being updated all the time. So you have to figure out how you're going to roll that out without getting everything out of sync. And, we say we can write once and run everywhere, but it's nice in theory until you need to run strace to figure out a regression on production, because something's not actually running everywhere. You need comprehensive automated testing. I mean, it goes without saying. And yet I still see significant changes that lack test coverage. It can be difficult to test legacy stuff with very complex dependencies. If you're integrating with third parties, it can be difficult to test that. The banks are notorious for this. So it can be very difficult to do that on parts of the code, but you need automated testing. And adding tests at first can have a large negative impact on velocity. It can slow you down in the short term, to even the medium term, but it should become a large positive impact in the long term if you do it right. And one point I want to make is there's no such thing as a one-line or one-character change, unless that change is only in the test. And once you have tests, you need continuous integration, which means more infrastructure. CI needs its own infrastructure. And how easily can you build that up and tear it down? And how close does it represent or resemble your prod architecture? Our continuous integration infrastructure is auto-scaled like AWS, but it's not quite like our production infrastructure because we don't use a shared file system. We don't have an EFS in place, so we're not going to catch potential issues in file system. What about firewalls? Those kind of things that you might not have set up in your CI architecture versus prod. You might deploy something and it can't speak to what it needs to speak to because the test didn't catch that. And you can get failures in the CI pipeline that are actually failures in the tool chain. So we do see this more than we see actual regressions in the test coverage in the code. But we prefer that. We prefer false negatives than false positives. If CI fails and we hit retry and 2 minutes later it's passing again, it's probably an issue, transient issue with something in the CI system, pulling a container failed or whatever. And you need a review and QA process. And really anything that can be automated here should be in the testing. So like linting and all that kind of stuff. Again, it depends on the state of your code. And you want to formalize the review process and apply it to all of the merge requests, no matter how trivial, obviously with good judgment to allow exceptions. And you need staging for the bigger changes, maybe for all the changes. And it probably wants to be part of the review process because you might want to get user acceptance testing from clients or internal users of the system. And a key thing here is the staging environment might inform your release process if it's not trivial. So if you're having to make big architectural changes or you're moving things around a lot or you're upgrading the database, then do that on staging first and then figure out how we're going to do this on prod. Is it actually relevant for the continuous deployment process? Or are we going to actually need a maintenance window? And you're going to need an internal toolchain, so deployment scripts. There's a few things here and there available for this, but I find that your architecture is probably going to be your architecture, and it's going to have its own quirks and edge cases. So you're probably going to end up having your own deployment tools. Schema migrations and updates in the database. Again, there are tools for this, but again, it depends on what's the state of your schema and your database and your data store. How easy is it for you to update, roll back? What's that look like? Do you have multiple replicas? We have multiple replicas, so we need to be aware that if we make a change in the schema, that's going to go onto the replicas, and it's not just going to be this big a spike, it's going to be this big a spike times X. So that's something to consider. You might need repository management tools if your team and development process is big enough. You know, the FANGs have got such large development teams and often using monorepos that they need to have tools to manage their tools. You can need monitoring and by association alerting. And you're going to need an external tool chain as well. So you're going to rely on tools built outside of your company. I mean, it goes without saying, we work in the open source, most of us. So we're using third-party tools. And you need to choose wisely, but couple loosely, I think, my advice there. Easier said than done sometimes on both points. What are we using? We're using GitLab. We use AWS. And as I said, we use AWS for our CI servers. So there's a lot of dependency there on a third-party tool. And again, you need monitoring and alerting. So we're using Grafana, Kibana, these kind of things to monitor and then chuck out alerts if need be, which I can demonstrate in a bit. And you need a rollback feature. So you're going to need to roll back at some point. It's inevitable. And it needs to be built into the deployment process. What we do is we tag every release to each region. And we annotate our monitoring dashboards with those tags so we can see precisely when a release goes out. And if we get a spike on some graph somewhere, it's easy for us to see that oh, look, it coincided with the release. Perhaps this change was responsible for the change. But because of those tags, we can roll back quite trivially to previous releases. It's very easy to see where we were and where we can go back to. And if you do release frequently using continuous deployment, this is easier because your change sets tend to be smaller. So it's easier. You don't have to pick the bones out of a release to figure out what state we need to get into. And then you need to think about the database or the complex deployments. As I said, it's always a database. It's a problem. So we have feature flags in a lot of our platform, which allows us to roll out some of the database changes easier. I mean, I say some of them. It depends on what the schema changes precisely. If we're adding new tables and new columns to tables, then we can kind of hide some of that behind feature flags. But you're still going to have to babysit significant schema changes. There are tools to do this in a no downtime approach, but it depends on what you define as downtime. Is degradation of the service downtime? What are your SLAs? What do they define as an outage or, that kind of degradation in service? And one way we do this is to try and make them backwards and forwards compatible. And then when we're happy that everything is fine and working and the features switched on, we can remove the backwards bit, which doesn't always happen. And then we try to deploy them during the quiet periods of the month. As I said, our traffic patterns are very specific. So we know that it's the middle of the month. On a Wednesday morning, the traffic is 20% of what it would be at the end of the month. So the risk is lower, basically. And you need to check once changes hit production. So how do the original developers know that their changes have been deployed? Depending on how your team is set up, you might have somebody else handling the deployments compared to who's made the change. Especially if you're kind of doing agile and you're having a sprint and you've got all this work ready to go out, or it's work that's been worked on by a junior dev, then been reviewed and it's gone out. You want to feed back to the original developer or developers that their changes hit production, if it's a kind of change that needs to be verified in production. So what we do is we send notifications to Slack and email. So every time we do a deployment, as I said, we tag the deployments and we send a message to a Slack channel, which has a list of all the merge commits that went out in that deployment. So then you can trivially click through to GitLab. And you could @, people in Slack because, if it's the author's name in Slack, then you can @ them so they can see their changes gone out. And you need to continuously deploy all the internal things first because this is a good proof of concept. And internal tools probably don't affect the bottom line in that them breaking for a short time probably isn't critical, as in it's not customer facing. It's annoying if the internal tools get broken, but that's not production. Production is still up and it might waste a couple of hours internally, but better than the alternative. And you probably don't have to fix those internal tools outside of office hours. And this kind of then feeds back into the tool chain. So it encourages development of the tool chain that you're gonna then use to deploy to production. So how far have we got at PayProp? So we have full continuous deployment on our internal tools. We have a translation manager, so that handles translations on the platform, our DB extract and backup scripts, and then the deployment scripts themselves, which is a bit meta. So the deployment scripts are continuously deployed, which encourages the development of the deployment scripts. And we have what I'm saying is semi-continuous deployment elsewhere. So what we have is a one-click to deploy to everywhere, which is kind of, again, a nice compromise. So what we have in our GitLab server, it's a bit small here, but it's fine, is once a change hits mainline, we can view the pipeline, we can confirm that the build is built, the tests are passed, the sanity checks have all passed. And then there's one click deploy to everywhere, or we can deploy to different regions. And one of the nice things is because we're working in North America and Europe, when we're in the office in Switzerland, the UK, Stellenbosch, it's generally outside office hours in North America. So if it's a significant change, we know it's 3, 4 o'clock in the morning in the US and Canada, so we can get it out there first and then be happy with it before it goes out to the European regions. So the pipelines kind of look like that. One of the nice things that's just worth mentioning here is the way we've got the test runners is we have split up the test run into subdirectories. So we have unit tests, integration tests, modulicious tests, sanity tests, and we have a container that's used for each one, so we can parallelize the test run, which is quite a nice optimization on the continuous integration server. And when we do this one-click deployment, we get all of the trace that we get from running the deployment scripts, and we can any issues there in the tool chain, which sometimes happen, we can see the trace output and debug it. And that's about all I've got. What I said here is, do you want to ask questions, or would you like some bonus slides? And the bonus slides is just kind of a small look at some of the systems we've got in place and how we use them. Bonus slides? Okay, right. So I might have to sit down to do this. Yeah, no, it's fine. So if I basically show the pipelines that I just mentioned. So as I said, we only obviously deploy stuff from mainline. We can deploy work from branches if we want to, but the way it's set up here is you'll see that we have these. Let me make this a little bit bigger. So we have basically pipelines here. And if I go to branch name master, you'll see we have more steps when it loads in the pipeline. So if I click through to this one here, we've got some front-end tools that get built and then some other build that runs. So we've got pages. Then we have our tests run. And at any point we can rerun these jobs if need be. And then our pre-deployment steps. So one of the pre-deployment steps we have is a check if there are any database changes. So we use schema migration scripts. And if one of those is in the stuff that's going to go out, then this will flag it up and say, hey, there's a database change here. You might want to just double check that what you're going to deploy, does it need it, or is it something you can roll out at a later stage? And then we have the deployment steps itself. So if I go to here, basically this is the Perl script that I mentioned that is configuration driven, and it deploys from a deployment box which just contains the Git repos. So it's deploying from Git, as it were. We git pull and then sanity check stuff and deploy it and restart services as need be. This figures out from AWS where it needs to deploy to, because as I mentioned, we're using auto scaling. So we could have 20 servers and we need to figure out where we're deploying to. And it also has sanity checks in place. Sometimes the deployment process can take long enough that a server may have been taken out of the pool. So it handles all of that basically. And then we restart some things, restart some services at the end, and we tag, as I said, we tag releases here. This then goes out to a Slack notification and email notification, and also is it that? No, it's not there. So if I go to this is the monitoring dashboard, one of the monitoring dashboards for the application. So we've got basically the database and how many web servers we have in place and all the other kind of stuff. And the key thing here is we've got annotations. So I can basically get through to the change and see the exact change that went out. So this has been key in removing a lot of the time taken to figure out what's gone wrong when we deploy code and then we start to get support calls. So we had one about 2 weeks ago, and it was only a cosmetic change. It didn't actually affect functionality, but it resulted in a lot of support calls because the users were seeing something they weren't used to, and they questioned what was happening. And when those support calls started to come in, we could see exactly what had been deployed when, and it was easy to immediately see what the problem was and then roll it back and rethink it. And yeah, there's not much else to show. I didn't want to go too much into the guts of how you set up a GitLab runner and all the YAML configuration and stuff, because you can find that online. Any questions? Yep.
Got breaking changes in your predeploy. How do you handle that?
So if the pre-deploy step realizes a database change, the pipeline stops at that point, and you have to force a deployment. Basically, you have to do it manually and confirm, yes, I want to deploy this code. It still needs some manual intervention, perhaps, because if it's something you need to sync, we're adding a column to a table, but we need to do that before we then restart the services. That's when we will get manual intervention. So we'll deploy the code without restarting anything, then make the database change, and then restart things. So that's what I mean by it's kind of semi-continuous deployment, because it's difficult to code around those kind of changes because everything needs to be synchronized, unless you're bringing up a new database and then you're kind of hot swapping things across, which we're not at that level basically. Any more questions? Yep. So the question was, when I started, we had system Perl and different versions of module. How difficult was it to change that? So the way that we did it is we basically built Perl and installed it in a Git repo. And because we have consistency through our environments, we have very little issues on deploying that to everywhere, because everywhere is the same. We haven't looked at what we're going to do in the future, because we can obviously start containerizing things and then it's going to change significantly. But no, because it made it easier for everybody, because they didn't have to manually install Perl and all the modules. They just get pulled from a repo onto a dev machine and a VM, and it just worked. I mean, I say it just worked, but it just worked 99% of the time, which was, a big improvement. Any more questions? No? Okay, great. Oh, one more question. Do we use any container orchestration? We don't yet. As I said, we started having developers join a year or two ago when the M1 Max just came out, and that did affect the tools Perl, because it's compiled for Intel, not ARM. So then we had to look at using Docker and getting that environment working. So that's very much in the early stages, in that we have development environments where we can use containers, but we haven't started thinking about how we're going to roll it out to production, which is going to have to happen at some point. Yeah, we use Puppet and Terraform for the AWS stuff, so that's kind of orchestration, but it's not containers, it's more server level. And I think I'm out of time, so we'll leave that there.